So when we are talking about division 1 and division 2, so we are going to see what are the core differences between these two. So far all of you are with me. So you can just raise the hand or you can say yes so that we can move ahead. I hope my speed of talking is relevantly moderate so you all can understand. Right? So far we have seen that how the technology is going to get changed and why we are saying that division 2 is the future, right? The reason being the pressure ranges into which that technology demands division 1 will unable to cater that requirement. So now let us see what are the core differences between division 1 and division 2. So we are going to see the three columns. First will be the parameter which we are going to compare between division 1 and division 2. So design methodology. When we are dealing with division 1 and division 2, what are the design methodological changes? So division 1 is focuses on design by rule approach, where we are giving or we are using all the equations like let's say for shell thickness calculation, we are using UG27, PR upon AC minus 0.6 kilo. If we are using UG32 for let's say the calculation of elliptical head. So PD upon 2AC minus 0.2 P. That is what the small equations given and those equations we are using. So design by rule approach will be used or rather is used in division 1. Whereas in division 2 provide design by rule in detailed approach. So here there is a simplified approach. Here there is a detailed approach. Along with that there is a design by analysis approach as well. If we know in division 1, we cannot use directly the FEA. If the rules are given in division 1, we have to follow the rules. If those are not given, then it falls under U2G and then only we have to refer to some other methodology which could be division 2, part 5, which is design by analysis or some other methods, right? So division 2 has both design by rule as well as design by analysis. So if you are having class 2 vessel, you can be able to design entire vessel with the help of FEA as well. Then comes the factor of safety. So when we are dealing with ASME section at division 1, specifically, we can see on ultimate tensile strength, the factor of safety mentioned in the code is 3.5. So is it mentioned in division 1? The answer is no. It's mentioned in ASME section 2 part D mandatory appendix 1. So is it in division 1? No, it is given in section 2 part D mandatory appendix 1. So what is the factor of safety for division 1 on ultimate tensile strength? It is 3.5. Whereas when we comes to division 2, there are two classes, class 1 and class 2. For class 1, the factor of safety on ultimate tensile strength is 3. And for class 2, it is 2.4. So in short, what we can say, for the same material, you can say the allowable strength or allowable stress would be lower in division 1 and higher in division 2 because the division factor is 2.4, here it is 3.5 and for class 1 it is 3. So whether it is given in the code, so this is a snap has been taken from ASME section 2 part D mandatory appendix 1. So here we can see in table 1-100, this is for ASME section and division 1. So what is the factor of safety given on ultimate tensile strength? It is 3.5, right? And when it comes to, let's say, the class 1 vessel, so we have to refer to table 2-100A. Here you can see on ultimate tensile strength, it is given 3. Here it is 3.5, here it is 3. And when we are dealing with class 2 vessel, we have to refer to this table. Here you can see the factor of safety mentioned on tensile strength is 2.4. So in short, what we can say, the allowable strength or allowable stress for division 2 vessel will be higher as compared to division 1. So technically the thicknesses would be lesser if we are going to design it with the help of division 2. So now let's shift to the next important comparison. So recommended maximum pressure limit. In division 1, the maximum pressure limit has been mentioned as 3000 psig. And if you want to use division 1 above 3000, then you have to use the equations from division 2 only. So what we can say, division 1 equations can be able to use the pressure up to 3000 psi only. And when it comes to the division 2, it is up to 10,000 psi. The lower limit for both is starting from 15 psi. So here it is 15 psi to 3000. Here it is 15 psi to 10,000. So it is called as an design by rule. This is called as an alternative rule, right? So all the pressure vessels which can be designed with the help of division 1, which can be having a pressure range lower than 3000 psi, all can be very well designed with the help of division 2 as well. But the upper limit is 10,000 psi. When it comes to the failure theory of design, when it comes to the failure theory of design, those who are having any queries or questions, they can just write it down. So at the end of the session, we'll be having one by one all the questions. So failure theory of the design, division 1 is based on maximum principal stress theory and division 2 is based upon von Mises criteria, which is comes under maximum distortion energy theory. If we look into the solved examples given in ASME PTB manual, if you are going to calculate the stresses for combined loading, you will come to know there it has been mentioned that maximum stresses or maximum principal stresses what we are using in division 1, and for this we are using the von Mises criteria. Fatigue evaluation. As per division 1 UG 22 loading, it has been mentioned what are the probable loads which will be coming on pressure vessel. So there they have mentioned that fatigue or cyclic load can come on any pressure vessel, but division 1 does not give you any methodology how to calculate the number of cycles when it under cyclic loading. So division 1 does not have any direct methodology. So we are going into U2G and ultimately going into division 2 part 5 to use that methodology, right? Whereas division 2 have the part 5 for fatigue evaluation directly available. So for fatigue evaluation, division 2 is having the direct methodology. Then comes to the design rules. Let's say part 4 is what given in ASME section and division 2, under which all the design by rules equations has been given. Whereas the UG part, mandatory appendix 1 and some other mandatory appendices are given in ASME section and division 1 for the calculation purpose. So basic simple design rules is what has been used in division 1 and more detailed analysis as compared to division 1 when we are talking about design by rules. So let's see some of the examples. So let's say we are going to calculate the thickness for elliptical head as per mandatory appendix 1, or let's say here the equation given PdK upon 2AC minus 0.2P. So by using this simple equation, we directly can be able to calculate the thickness. Is it an iterative method? No. We are directly going to put the geometrical and allowable stress value and we are going to get the thickness directly in one calculation itself. So it is very simple. But when it comes to division 2, part 4, it is not that easy. So the elliptical head, particularly if we are going to compare, so here we are going to have the knuckle and crown approximated for elliptical head. They have given these equations. So with the help of that, we are going to calculate it. Then the K factor, which depends upon the major to minor axis ratio. Thereafter, we have to calculate the multiple things. That is, L by D has to be between 0.7 to L. These criteria they have given. Then we have to calculate the geometric constants like beta TH, then psi TH, phi TH, R TH. So these are all the geometrical parameters and the constant what we have to calculate. It is a multi-step procedure and on top of it, it is not a single go method. It is an iterative method where we have to first assume the dimensions and the thickness and then we have to calculate the various stresses. If those are within limit, then only the given thickness is okay. Otherwise, we have to change the thickness and again we have to calculate the things. So here we have to calculate these geometrical constants. Then we have to calculate these PCK. What is this PCK? This is called as the value of the internal pressure expected to result in buckling failure of the knuckle. So CK stands for the knuckle. So we have to calculate the pressure at which there will be a buckling failure in the knuckle going to get observed. So this is the equation what we have to use. G is another parameter. What PETH and PY we have calculated, that we have to use over here. So then we have to calculate another allowable buckling failure pressure for knuckle. We have this calculated for what? Buckling failure of the knuckle. This is also buckling failure of the knuckle. So this is PAK, which is equal to whatever the PCK we have calculated, divided by 1.5 as the factor. So once we have calculated this, then we have to calculate the pressure based upon the rupture strength of the crown. So we have to calculate PAC, C for the crown, K for the knuckle. And after that, we are going to get the final maximum allowable internal pressure, whatever geometry and the thickness we have assumed, how much maximum pressure that can sustain. That PA we have to calculate, and that we have to compare with the design pressure. If this allowable pressure is more than design pressure, whatever assumptions you have done, that is correct. If not, then you have to change the thickness, and again you have to start with this procedure. So the procedure, what was very simple, one go method in division 1, here it becomes multi-page procedure when it comes to division 2. That's the reason why it is called as much detailed analysis. As the factor of safety is on the lower side, you are taking higher allowable strength. So that's the reason why the analysis has to be in more detail, and that is what has been happening over here. So let us take another example. Let's say if we are going to calculate the thickness or allowable pressure for external, if there is an external pressure on the cylinder. So how we are going to calculate the thickness? In division 1, what we are doing, we are calculating L by DO, DO by T, then we are calculating factor A, then we are calculating factor B. And once factor A and factor B have been calculated, we are calculating the allowable pressure. If we are having factor B, we are using this equation, 4 by 3 B upon DO by T. So this will give us the allowable pressure. That has to be more than the design external pressure. Let's say if design external pressure is full vacuum, which is 15 psi. So if your PA value is more than 15 psi, your design is safe. If it is lesser, then you have to either increase the thickness or you have to incorporate the stiffener rings, and you have to re-perform the calculation. And if factor B is not found, then you have to use factor A and 2/3 AE upon DO by T. So this is the equations and the procedure what we are following when we are dealing with external pressure for the cylinder in division 1. Correct? So this procedure no way similar to what is given in division 2. It is way more different than what is given in division 1. So when it comes to the division 2 for the external pressure loading, they have given 4.4.5.1. So here we have to calculate predicted elastic buckling stress, FHE. This is what the value we have to use. This is based upon the dimensions. RO is nothing but the OD by 2, that is outside radius. L is nothing but the length. Then CH, these are the factors what we have to calculate. These are again the dimensional factors. So we have to calculate first the predicted elastic buckling stress. Then we have to calculate predicted inelastic buckling stress, FIC. One is elastic, another is unelastic. Then we have to see the design factor FS, and then we have to finally calculate the allowable pressure. So when it comes to the FIC calculation, right? FIC, which is inelastic buckling stress. So we have to use 4.4.3.2. These are just the numbers. This is not in detail what we are covering. We are just giving how the calculations are going to get differ when it comes to division 1 and when it comes to division 2. Division 2 is way more detail as compared to division 1. So here this FIC upon ET is equal to AE. FIC is what we have to calculate. And for that, they have given the methodology in Annexure 3D and 3D 5.1. So this is what the program what they have given. So this program is nothing but an iteration loop what you have to follow to calculate the FIC value. So it is very complicated, isn't it? So they have given some program. But we have made it very simple. With the help of simple equations also we can use it. Excel is the tool what we are going to use. And in the if you are going to have it in the course, you can see that very simply we have done that. But otherwise it will be very, very difficult to get into the details of FIC. So once you have calculated FIC, then ET, D1, D2, D4, these are the parameters what you have to use. And you have to calculate this elastic modulus. And once you have calculated that, then you are going to calculate this allowable pressure. And if this allowable pressure is more than your design pressure, your design is safe. But here it comes the iterative method, right? Here it is pretty simple, though it is also iterative, but here we are not going to use such loops, right? Or the computer programs to calculate the value of FIC, because this FIC depends upon two parameters, and these two parameters again depends upon one another. So it is a deadlock. So we have to go into the multiple iterations to get the equation solved, and then only we'll be going to get the value of FIC. And once FIC is been known, then you can be able to calculate the allowable pressure. So this is what the procedure given. This is for cylinder. Same way the iterative procedure has been given for all the dished ends. Here it is pretty simple. There are only two equations given. Once we have calculated the factor A, the formula also has been given. There is no L by D or U by T. So in division 1 for dished ends, the calculation of the allowable pressure for external pressure is very, very simple. As compared to division 2, it is 4-5 pages calculations which will come into the picture. Then let's move to, these are the core differences in nutshell what we are going to see. When you are going to design non-standard flange as per division 1, what we are going to do? We are going to use mandatory appendix 2. So as per that, we are going to calculate two moments. One is called as the operating moment, which is nothing but the addition of MD, MT and MG. So we are going to get operating moment and we are going to get the gasket sitting moment. Out of these two moments, we are going to calculate the stresses. This is what the procedure is. Correct? So similar to this, in division 2 also we are going to calculate the operating moments for internal pressure as well as for external pressure. So this is same. Correct? So is exactly the same procedures are there? The answer is no. In division 2, they have given if there are some external forces and moments coming onto the flange, how to take care of that. Division 1 totally does not cover that part. If there are any external forces and moments which are coming onto the flange, how to take care of that in the design. But in division 2, they have given MOE, that is moment resulting from the net section bending moment and axial force if axial force is tensile in nature. So they have given this equation with the help of which we can be able to calculate one more moment, which is nothing but the moment caused by external piping loads or any other loads, right? So here they have given these equations. With the help of that, we have to calculate the external moment. Here IP and I, these are the moment of inertia and polar moment of inertia, what they have given. So here you can see for variety of the flanges, for integral flange, for loose ring flange, you have to calculate the moment of inertia and polar moment of inertia. So this is quite complicated as compared to what we have seen in division 1. So division 2 also covers the moment caused by the external forces and moments, and they have given in detail procedure to calculate that. So far we have seen the basic differences in the normal equations and in division 2 part 4, which are much more detailed as compared to division 1. When it comes to the use of FEA, division 1 does not allow to directly go to FEA if the rules are given in division 1. However, in division 2, if it is class 2 vessel, you can directly be able to go for FEA. The entire vessel can be designed with the help of FEA. So that is an advantage where you can optimize the design. Most of the professionals who have given in the chat window, they have mentioned that, right? So we can be able to optimize this. So division 2 gives you the access to part 5, which is nothing but design by analysis. Then comes hydrostatic test pressure. In division 1, as per UG 99B, we are going to use the equation 1.3 times the MAWP into the lowest stress ratio. So here the multiplication factor is 1.3 and for pneumatic it is 1.1. When it comes to the division 2 for hydrostatic test pressure, it is only 1.25 times of the MAWP or design pressure. The pressure is lower as compared to division 1 due to the increased extent of NDE and the methodologies what has been given in division 2. So division 2 has 1.25 times and division 1 is having 1.3 times of MAWP. Load combinations. In UG 22, various loads have been mentioned. But how the load combination works together. So what are the load cases that you have to consider when you are going to perform the combined loading calculations? Division 1 does not have given any of those. But in division 2, they have given in table 4.1.2 in detail the load combinations. Let's have a look at. So these are the load combinations what we are talking about, which are very nicely mentioned in table 4.1.2. So here P, PS, D, these are the various pressures, then static head, then dead weight. These all terminologies have been mentioned over there. So there are total 8 load cases, what has been mentioned in division 2, which are compulsory to follow. And if there is some other load case is coming in your particular pressure vessel case, then you can include that as well. This is not limited to it. If any other load cases are possible, you can include those. But they have defined these 8 load cases. W stands for wind, E stands for the earthquake. So similarly, they have given the table 4.1.2 to take care of the design load combinations, which are totally missing in division 2. When it comes to the support calculation, right? So in division 1, they have not given any procedure to calculate any stresses when it comes to the support part. Whereas in division 2, if we are calculating for the saddle stresses, they have given the detailed methodology. So let's have a look at. So this is the procedure what has been given in division 2 when it comes to the saddle design 4.15.3.2. So here we are going to calculate the moments, and after that we are going to calculate the variety of stresses. So here longitudinal stress, there are variety of the criteria given. So as per your requirement, you have to calculate these stresses. Then shear stresses you have to calculate coming on to the distance near to the shell, then on to the area where it is been connected with the vessel. Whether it is very closer to the distance or it is away from the distance, accordingly these equations will change. So shear stresses we are going to calculate. Then whether there is a stiffening ring provided or not, as per that we are going to calculate the circumferential compressive membrane stresses. So longitudinal stress, shear stress, compressive stress at the horn of saddles we are going to calculate. So these are given much in detail when it comes to the division 2. Right now also, if we are going to use the calculations, let's say we are using PVLEAT as a software, we are going to use the same zip method what is given in division 2, and we are going to calculate the stresses as per the guidelines given in division 2 only. Division 1 does not have given any guidelines to calculate the stresses caused by the saddles at various locations. And the final thing, which is also very important, actually this thing is going to incur the higher cost as compared to division 1 when it comes to the analysis part. International professional engineer certification required, or we can say the chartered engineer requirement is there. So whenever we are certifying engineer, so in mandatory appendix 47 of division 1, the certifying engineer is required only if you are dealing with what? The fatigue analysis. In case of division 2, class 1 and class 2, if you are dealing with the fatigue analysis, then UDS. In division 1, there is a requirement or form called as the UDR, which is user design requirement, which comes under non-mandatory appendix, which is not compulsory. But here in division 2, UDS, which is called as the user design specification, which comes under mandatory requirement. And if there is a fatigue analysis required, then UDS needs to be signed by an international professional engineer, and there will be charges for the same. So for UDS purpose, you have to have the stamping done from the professional engineer. And if there is a fatigue analysis required, then even your design calculation reports also to be stamped by the professional engineer. So professional engineer can be required at 2 times. One, when there is a fatigue requirement, then the UDS also required to be stamped by the PE. And if the manufacturer design report, including the fatigue analysis is there, that also to be stamped by the PE. You cannot use the same professional engineer for UDS and for the manufacturer design report, right? Because that will be the conflict of interest. UDS is the document which will be submitted to you by the customer. So that customer have to engage some PE, and that PE have to certify the requirements. And after that, the manufacturer is going to perform the calculations, and those calculations will be approved by another PE. So if there is a fatigue analysis, 2 different PEs are required. That is also very important thing. So these are the changes what we can by and large say between division 1 and division 2, which makes division 2 more in detailed analysis, and it gives you very optimized thicknesses as well. So let us see why we are saying ASME section and division 2 can be a future or will be the future. We just have a look at the recent changes what has occurred in ASME section and division 1 in 2023 edition. If we just have a look at what are the changes. So part UHX, when it comes to the part UHX, you all must be aware, whenever we are going to calculate the tube sheet calculations, there is a separate part given UHX, out of which in the previous version, there was UHX 13 given for fixed tube sheet, UHX 12 given for U-tube heat exchangers, and UHX 14 given for floating tube sheet calculations. So part UHX was covering all the requirements of the calculations. But in recent changes in 2023, so this was the scope, right? In the older version, 21, and this is in 23. You can see over here 23, right? So here earlier UHX 1, 2, 3 till UHX 20 were there, right? And in latest edition, UHX 3 to UHX 17 have been omitted and they have given directly reference to division 2. So now, if you are having division 1 only, you will not be able to design the heat exchanger. For that, you need to have division 2 as well, and you have to refer to part 4, 4.18 to be specific, if you are going to use the calculations. So, here you can see in the latest edition, after UHX 1 and 2, directly UHX 18 has come. All in between things have been omitted and they have directly given a table to us like this. So these are the various topics and these are the references from division 2 what you have to refer. So for scope, you have to refer to 4.18.1. For fixed tube sheet heat exchangers, you have to refer to 4.18.8. For floating head, 4.18.9. And for U-tube, it is 4.18.7. So only with the help of division 1, now we are not in a position to perform the calculations. Even for the jacketed vessels, bolt flange connections, bellow expansion joint, for mandatory appendix 26, you can see that these are all the references. So mandatory appendix 9 is for jacketed vessels. So earlier mandatory appendix 9 was covering all the requirements for the jacketed vessel. Now they have again given the reference of 4.11. So you have to go to division 2 for that. For mandatory appendix 2, 4.16, they have given the cross reference. But still in mandatory appendix 2, they have kept all the equations. But that is not the case with mandatory appendix 26, which is for the flexible or bellow expansion joints. Bellows, what we can say that the thin bellows which we were using as per mandatory appendix 26, let's have a look at how they have got changed. So this was earlier scope, this is new scope as far as mandatory appendix 26 is concerned. So here you can see in mandatory appendix 26, this table has been newly added. What does that tell us? That the scope you have to refer to 4.19.1. So at multiple locations, you can see now the division 2 references have come. So can we say that they are slowly eliminating the things from division 1 and directly referring to division 2. So maybe in very recent future, we can see that the division 2 could be the reality. So does division 1 will totally be obsolete? The answer will be there in upcoming years. It may happen in couple of years or 4 years or 8 years as well. But it is definitely going to happen because we can see that most of the things has now been removed from division 1 and have been given in division 2. So this is what, in short, what was our today's topic, why we can say that division 2 would be the future. First thing is because of the technological changes what are going to be there. So that technology is demanding for the higher pressure and that pressure may not be able to use division 1 formulas, right? And for division 2, actually there are so many advantages and division 1 latest changes also suggest that division 2 references has been given to us. So all of you are clear about that? So guys, now if you are having any queries or questions, you can certainly ask. So we have just seen that division 1 and division 2 are not that similar, right? So there are total difference in the calculation procedure and the methodology. So guys, if you are having any queries or questions, you can certainly raise the hand and I'll answer your questions. So guys, we are having our own application where all these videos will be available. There are division 1 videos there. This video will also be available over there. There are pipe stress analysis calculation free videos available. So I'll just give the link in the chat window. You can download from that our app and you will be able to have the access of that as well. So if there are any queries or questions, you can certainly ask. Yes, Manoj is asking one question. I'm just unmuting Manoj. Yes, Manoj, can you be able to hear me?
Yes, sir. Sir, I have one question.
Go ahead.
In section one, there is for 2 inch and small nozzle, we need not to perform reinforcement calculation.
Correct.
Uh, Similarly, in division two, is there is any clause
No.
so that we don't need not to perform reinforcement calculation for small nozzles?
Since you have asked for this, so in division 2, we are not using area by area compensation method. In division 2, we are using directly the methodology by which you are going to calculate the stresses at the nozzle junction and at the shell junction. If you look at 1-7, right? In division 1, there what we are doing, we are not doing area by area compensation there. We are calculating the actual stresses developed, right? The same thing
Yes.
is given in division 2. So there is no such a criteria where we can have these reinforcement calculations not required. Is it clear?
Yes, sir.
So in division 1, we are using very simple approach. The area what we have removed, we are providing that area again, right? But that is no more the case in division 2. It is way much detailed analysis when it comes to division 2. We are actually calculating the stresses over there.
Okay.
So
Sir, my second question is in division two, there are two classes, class one and class two. Okay. ASME section in division two, class one, class two.
yes.
Hello.
Yes, I can hear you.
So,
So there are
we are
class 1 and class 2. So what is your
yes,
question?
we are for optimization in design. We are using class two. Then when class one is useful for us,
So
and
usually,
for
if we just have a look at class 1 and class 2, class 1 was the recent addition, right? Class 1 was not there since long. Class 2 was there, and class 2 is usually used for the standard pressure vessels. But there are some applications where they want to have more factor of safety. So for that purpose, this class 1 has been introduced, and there it is more critical applications where this class 1 has been used. There the factor of safety is 3, and there you are having the higher thicknesses, which gives you more integral vessel. So this has been the recent addition. So guys, we are having most in-depth trainings on our platform. So when it comes to our training, it always been said that no one can decode the code like us. You can see each and every step of the calculation has been manually performed and every answer has been matched with PVLead as well as compressed software also we have used for the validation wherever division 1 PVLead or division 2 PVLead has some limitations. So even we have used compressed software for that validation purpose and very in-depth detail lectures are there. More than 3,000 slides and videos are there. So it is wonderful lectures what we have prepared and if you are just going to go through those you will definitely be able to empower yourself to design these ASME section and division 2 vessels. So this is not just the sessions or the videos or the lectures where you just going to have some glimpses of the knowledge. Rather, each and every step you are going to see in much detail in all the calculations. Just for an example, if we are going to see in division 2, a simple thing, what we can call it as external pressure calculations, right? So in external pressure calculation, you can see all the details what we have covered. So all the procedures has been very nicely and in detail cover over there. Right from the step number 1, you are going to see it, the equations, whatever we have seen, right? The elastic buckling, non-elastic buckling, how to calculate the FIC, how to calculate the variety of the geometrical parameters. These all things you can be able to see over here in detail explained, as well as there is a manual calculation has been taken, and that has been solved to the very extent where you can see the answers matching with the PV software as well. So every step has been performed in detail. So if you just have a look at, so each and every substitution has been done, and every calculation has been performed to the level where you can also cross check that thing if at all it is required to. So how these things will be done, everything, every step, every small equation has been solved, and the answers have been matched with the PV software as well as. Even the iteration procedure has been given. So that procedure, if we click, that will open, and how we are going to calculate that FIC value after iteration. So that has been indicated in that. So all these things you can see in the very detail. Those who have done our pressure vessel division 1 course, they must be knowing that in what details we are performing the calculations and how they are getting empowered because of this. So each and every step. So let's say if the earlier step it is not getting satisfied, the allowable pressure was less than the requirement. So we have even done the calculation with stiffener ring, and the whole procedure has been repeated to the next level. So you can see each and every calculation has been done manually, and that calculation you can be able to witness through our courses. In chat window, you can see a number 9921 229232. On that number, you can reach to us for any queries, for any details. And those who want to have the free video lectures, they can download our app, and they can have the access to the free video lectures related to piping stress analysis, related to static division 1, and now the division 2 video of this will also coming over there. So thank you guys for your time. So if you are having any queries, you can go ahead and ask. So this is right now what we are discussing about the part 4 analysis. The course will be coming in. So the course will be coming on 1st of July. So every week there will be 2 lectures which will be coming over there. And after this part 4, we are also working upon part 5. So part 5 design by analysis is also coming on our platform. At the same time, you will be having the lectures on rotary equipment design, then API tank design, then how to face ASME use stamp audit, thermal design as per HTRI. So these are all the courses on which even Power BI, GD&T, all these topics we are, or rather all these trainings will be available on our platform. All these trainings are under progress. So in couple of months time, all these will be totally available on our platform.